It was great. Thank you for asking. How was yours?
Pretty good. I was saying.
All right, so we are on the back of page 29.
Wait. Oh, yeah. Oh, wait, it's right there. The dates are right there. Duh.
Fried chicken. Nah.
My number ready for letter F on the back of page 29. It got cut off, so I'm just going to say X minus 5. Gonna make that up. And that's what I'm going to say X plus 5. Yeah. Okay, so here we go. Who remembers from last time how I solved this? Remember what I have to do first. Combine the logarithms, that's exactly right. These, you cannot have two, right? Drill that in your brain, you cannot have two. When you put them together into one logarithm, what are you going to do with these two numbers? Multiply them. Why am I multiplying them? Because that is an add, right? Now, I have the log of this equal to the log of this. What is my next step? Don't want to loop-de-loop. I only loop-de-loop when I have a number over there. What? Nope, drop them out. So 4x equals x plus 5. If the problem looked like this, I would loop-de-loop. That's when I loop-de-loop. If I have a logarithm on both sides, if log equals log, then the numbers equal each other. So this equals that. So 3x equals 5 and x equals 5/3. G is exactly the same, except that's a minus. So what does that mean?
Divided.
It means when I put them together, I can only have one logarithm on each side. So when I put these two together, it's going to be a division, because that is a minus, right? Now I got log equals log, log them out, 2x over 3 equals 5, then what do I do? Multiply by 3, so x equals 15 halves. Right? All right, last one. You try it on your own. You and your partner. Same kind of problem. First step, what was your first step? Combine. And when you combine them, what did you combine them into? 3 over x. Perfect. Do we loop-de-loop? No. If this looked like that, then we loop-de-loop. But it doesn't. So we get rid of these. 3 over x equals 12. Multiply by x. divide by 12. So I got 1/4. All right, 3/5 is done. That's due on Wednesday. And now we're ready for our word problems. Okay? We have two formulas that we're going to use. We're going to do all of these word problems with just two formulas. You do not need to memorize them, but you have to know how to use them. So when we have a quiz or a test, I'll just write them either on the paper or on the front board here, and you will have them, but you'll need to know which one to use and what numbers to plug in where. So let's look at these two formulas. They're called growth formulas. They tell us how populations grow, or our money grows. For that matter, how does our money grow in the bank? Okay, so the first one we call the PERT formula. This is the continuous growth formula. So you will use this problem in any situation where you see the word continuous. Okay? You will also use this formula in any kind of nature problem. So in other words, if you have a bacteria culture, if you have a radioactive element, if you have anything from nature, this is your formula. Okay? So when are we using it? If the problem contains the word continuous, and some problems will, you'll see it here in our examples. If it uses the word continuous, or if it deals with nature, some kind of natural situation. In the formula, P stands for what you start with. So remember, we're talking about growing. So we're going to start with something, and then we're going to end with something. A is what we end with. E is E, Euler's constant. That is not a variable. It's on your calculator. Second ln gives you E. That's a number like pi. Don't substitute anything in for it. It's E. R is the growth constant. So the easiest thing I can equate it to in a money problem, that would be the interest rate. That's how fast this thing is growing. When you put it into the formula, it has to go in as a decimal. So if it's 6%, it's going in as 0.06. Okay, did everybody hear me say that? And T is time. All right, so all I'm gonna write on the board or on the paper is A equals PE to the RT. You have to know, first of all, when to use that formula, and second of all, what numbers to plug in where. And that's why we're going to practice. The second formula is your compound interest or compound growth formula. Most of you have a bank account, right? And you get, they give you interest compounded monthly.
Yep.
This is your formula. This formula is only used for money. Let me say that one more time. That formula is only used for money. And it's not a money problem, it's not that formula. The A and the P are the same. That is the number 1. It is not an L or an I or anything else, it is a 1. It's part of the formula. R is your interest rate. And again, it has to be entered into the formula as a decimal. So if it's 12%, 0.12. N is here twice. It's the same thing. Same number, just goes in twice. And N is the number of times per year that you compound. Some of you over there may not be able to see that very well. It's the number of times per year that you compound. So if your bank compounds monthly, then N would be 12. If it compounds quarterly, then N would be 4. So he's gonna read the problem. Okay? And then T is the number of years. So in the formula, T is the number of years. Alright, so I'm gonna write both formulas right here. So we have them in front of us. And now we're gonna start doing some of our problems. Alright, so 3-6. Problem number 1. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? Step 1, pick a formula.
Quarterly, 3 months?
Well, it's every 3 months, but it's 4 times a year. N is how many times a year? Which formula? Second one. So I'm going to use my second formula, and I'm going to start plugging stuff in. So how long will it take for an investment of 1,000? Okay, where does the 1,000 go? P, that's what I'm starting with. To double. Okay, now wait a minute, what does that mean? Well, I know, but that means if I'm starting with 1,000, I'm gonna end with 2,000. So A is gonna be 2,000. The bank pays 2.5% interest. So R is 0.025. Compounded quarterly, which is 4 times a year. So N is 4. And I want to know how long it's going to take. So T is my variable. Okay?
Yep.
Now, step 1. No.
Divide.
Distribute when you got power on there.
Divide.
Divide by 1,000. You guys, we talk about it for more than one day. When you got a number hanging out in front, get rid of it. So we're going to divide by 1,000. So 2 equals 1 plus 0.025 divided by 4 to the 14. Now what do you want to do?
Handle the 0.025 and the 4.
Figure this out, you mean?
Yeah.
plus 0.025 divided by 4. That step is completely optional. As long as you're not rounding off, it's okay. So we didn't round off, so it's okay to do that. Now what?
Put it to the fourth? Or would you?
Then you're gonna have to round off. Remember, we're trying to solve for t.
Okay. Get the 4 out. Knock the 4 out, I don't know.
Well, I gotta do something with the whole exponent, not just part of it.
Square root it? or-
No, I'm gonna take the logarithm of both sides. Because what happens to an exponent when I take the logarithm? Where does the exponent go?
Oh, to the back.
It comes right out here, doesn't it?
Yeah.
That's the beauty of logarithms. So 4t log 1.00625. Now remember, you're solving for t. You can do that now. What do you have to do to get t by itself? What do we need to do? You guys, I want to get t by itself, so I have to. How am I going to get rid of this thing right here? Divide. Absolutely, I'm going to divide by it. So the log of 2 over the log of that decimal equals 4t. Then what will I do? To get t by itself, I want to know what t is. I'm going to divide again. So I'm going to take whatever this is and then divide it by 4, right? So I'm going to type that top in first. So log 2, don't forget to close the parentheses if your calculator doesn't do it for you. Divided by log 1.00625. And I got a number. When I type this in, everybody should be typing this in. And then I'm going to divide that by 4 because I have to get rid of the 4. So you hopefully got 27.81 years. So you typed in this, it equals, and then divided that by 4 and got 27.81 years. See, this old lady's getting ready to wig out if I don't see a calculator in everybody's hand. Everybody needs to be typing this in.
I did.
We do not get good by sitting and watching. Test it. Half credit for getting the formula set up correctly, the other half for getting the right answer. If you can't type it in, you're gonna miss half credit on every problem, and guess what? That's an F. We're done with F's, right? Now type it all in, everybody's gonna get the right answer. 27.81, I have it written on the board, what are you doing?
No, I typed it in, but I was trying to figure out.
The only way to solve for an exponent is to take the logarithm of both sides. When your variable is up here, you guys, you're going to need logarithms. When your variable is the exponent, you're going to need logarithms because that is the only way you're going to be able to bring it down to ground level. You can't solve for it when it's upstairs. It has to be down on ground level. Okay. Next. Read the problem, number 2, and tell me which formula I should be using for problem number 2. Same one.
Yeah.
Because why? What's the key word?
Compound.
Compounded monthly, right? Compounded monthly. So here we go. How much will be in the account if $1,230 is invested at 0.03125, compounded monthly, so my N is 12, and I'm waiting for 10 years? I'm not going to use logarithms on this one. This is, they're handing this to me on a silver platter, because isn't my variable already by itself? So I'm going to type that in. Now a hint, I like to do my exponent first, so I'm going to make that 120, and then I'll use my exponent button. So I'm going to type exactly what I have written. 1230 parentheses, 1 plus 0.03125 divided by 12, close parentheses, raised to the 120th, $1,682.53. So if you type this in exactly the way I wrote it, this is what you should come out with. And if you're not coming out with that, that's when you either phone a friend or you get in here for office hours, so we can help you figure out how to type these things in.
Bang.
Now, again, why no logarithms on this one?
It's because there's not another number on it.
The variable is not the exponent. If x is up here, that's when I need logarithms. Otherwise, I don't use logarithms.
God, here.
All right, number 3. Read it. Figure out which formula you're going to use for problem number 3.
Do we say it?
Yeah.
Growth.
Well, all these are growth formulas.
Continuous.
Continuous. This is a PERT formula problem. Because, is it money? No. And if it's not money, it will not be that way. That one's only money. So here we go. How long will it take for a population of 450? Okay, where does the 450 go? P. To double.
So
What does that tell me?
2 out in front.
I'm going to figure out, I'm going to end up with 900, aren't I?
Oh.
Isn't that what I'm ending with?
Yeah.
I start with 450 and double it? E, the growth constant is 0.123, and I want to know how long it's going to take, so I am solving for t.
Yeah.
Now notice, where is t?
To the power.
It's an exponent. I'm going to need logarithms, but not yet. What is step 1?
Divide by 450.
Divide by 450. And when I divide, I'm going to get 2 equals e to the 0.123t. Now, I can LOG both sides, that will work, but it won't be as handy as LNing both sides.
Because ln will take
Because the
away
problem has an E in it. And when I ln both sides, this cancels. So ln2 equals 0.123t.
So then it's
Now,
just
kids, you can absolutely log both sides, but nothing will cancel. So it'll be more work. But you can do it. There's nothing wrong with doing that. It's just easier to do this. So finally, how do I get t by itself? Divide. So I'm going to take ln2 and divide it by 0.123.
Yeah.
And we should get 5.635.
Yep.
Now, there is a unit on that, but I didn't do a good job writing the problem, so we don't know what the unit is. This growth constant is 12.3%. Would you agree with that? That's 12.3%.
Yeah.
But I didn't tell you if that was 12.3% per day, then this would be days. If it was 12.3% per month, then this would be months. You see what I'm saying? I didn't give you the information you needed, but there is a unit here. There is a unit here, and it will be a time unit, like days, hours, months. I need to do a better job writing the problem.
So there will be like days on there.
There
Like
will be
it'll say.
some, and a real problem, there will be a unit here, yeah. All right, next problem. How much do I need to deposit in an account paying 4% compounded continuously if I want to have $35,000 in exactly 10 years?
Second one.
Which formula? Hurt. Look back at your notes. I told you there are two times that you used hurt. When the problem specifically uses the word continuously. Is the word continuously in the problem?
Yes.
When the word continuously is in the problem, you use PERT. It can be money. I never told you it couldn't be money. It can be money. Doesn't matter. That's finite. This is finite compounding. You have to have an end. You have to know how many times a year, and it's continuously. Right? So, if the problem says continuously, PERT. So, here we go. Let's start plugging stuff in. How much do I need to deposit in an account paying 4% in interest compounded continuously? So this is going to be 0.04. Where does the 35,000 go? A. What's P? What I'm looking for, right? How much do I need to deposit? Isn't that my unknown? And T is 10? You do not have to do this, but I always clean up my exponent if I can. So I'm going to multiply those two together and get 0.4. Now, is your variable in the exponent? No. No logarithms. Your job is to solve for P. Very simply, you're going to do what? Divide by e to the 0.4. And then you're going to go to your calculator. You're going to type 35,000 divided by second ln 0.4. And you're going to need to deposit $23,461.20. Okay. Number 5. Pick a formula. It is PERT. Why is it PERT? It's an element, it's a natural thing. Plus, the other formula, this guy right here, we only use with money. Does problem 5 talk about money? It can't be that formula then, it has to be the other one, right? Because we are only using these two. All right, here we go. Find the decay constant of an element if its half-life is 10.2 years. Now, do I know how much I'm starting with? Do they tell me how much I'm starting with?
No.
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 Do I know how much I'm ending with?
No.
Well, no and yes. I don't know exactly the amount, but don't I know it's half of what I started with? Isn't that what half-life means? So I am gonna randomly pick a number. Okay? Like 10. If I start with 10, then I'm gonna end with 5. Would you agree with that? Okay, let's just go with me for a minute. We'll see how this works. Let's just say that's what's going on. Pick 10, I started with 10 grams, I'm gonna end up with 5 grams. My decay constant, or my growth constant, I don't know what it is, but it's 10.2 years. Are you okay with that? I don't know R, but T is 10.2. Now, some of you out there are looking at me funny, you're thinking, Mrs. Wood, how did you know it was 10? I didn't know it was 10. I made that number up. What if I said I'm gonna start with 30? That would be okay. Then I'd end up with 15. And this is what my problem would look like. Would you agree with me?
Yeah.
Now, here's why it doesn't matter. What's step 1? What's step 1?
Yes.
Divide by 10. Boys and girls, what have I told you like a zillion times now about having a number out in front?
Get rid of it.
Get rid of it. What happens when I divide by 10? What is this over here?
2.
Point something. 0.5.
That's a half, isn't it? Now, what about this one? What if I started with 30? What's gonna happen?
It cancels out.
0.5.
Aren't I gonna end up with exactly the same problem?
Yes.
So the moral of the story is, if you don't know how much you're starting with, it's okay. Pick a number and end up with half of it. When you divide, you're gonna end up with this equation. Now, where is my variable?
Next one.
Okay, when my variable is the exponent, that means I need to log.
in here though.
But since it's an E, I will ln. So ln 0.5 equals, now look, those are gone. 10.2R. So now what will I do?
Divide by 10.
Divide. So ln 0.5 over 10.2 is my R. ln 0.5, don't forget to close the parentheses if you need to. Oh, wait a second. I got negative 0.068. Did you get a negative number?
Yes.
Does that make sense?
Yep.
That's supposed to be my growth constant. I got a negative number. What does that mean?
You said find the decay.
I'm not growing, I am decaying. When your growth constant is negative, it means you are
Decaying.
decaying. which we knew that because we went from 10 to 5. We're losing.
What about 10-4?
All right, number 6, take a minute.
What's the unit for that?
See if you can figure out which formula number 6 is. And see if you can set it up and figure it out. Problem number 6. Figure out which formula. By the way, 3.5 will be due on Wednesday. Some of you have already turned it in, but it's due on Wednesday. Problem number 6. What did you write on your paper? Okay, starting with that. So per problem. All right, tell me what you wrote. What did you put in for A?
391.
391. What did you put in for P?
198.
Yep. Easy. What did you put in for R? 0.222. And then T was T? Your variable? Notice where it is, right? So we're gonna need logarithms, but not yet. What is step 1? So 391 over 193. Do not be typing that in. That is nothing nice. Just leave it. Leave it. Now what? ln. So ln, this fraction, equals 0.222t. So what are we going to do? How are we going to get t by itself?
Divide by
So we're going to figure out what this is, and then we're going to divide it by 0.222. So ln 391 divided by 193 close parentheses divided by 0.222. I got 3.18.
Yeah.
Okay. All right, number 7. Read it and tell me which formula. Which formula?
A equals B, parentheses 1.
This guy, right? Because we are compounded monthly. Brian, gather your things and come on up. Come on.
I wasn't talking.
No, you're laughing and screwing around, both of you are. He's not blameless, but I'm only moving one of you. All right, so I'm using my second formula. So, here we go. Everybody clear on why I'm using that one? All right. How much will I have in my account after 12 years if I deposit 555? So 555 is my P. The interest rate is 3.5, so that's going to be 0.035. I am compounding monthly, so N is 12. and I am waiting for 12 years. And A is what I'm trying to figure out. So I always go ahead and do that, so I'll make that 144. Am I gonna need logarithms this time?
Nope.
No, in fact, aren't I just gonna type it straight in? So 555 parentheses, 1 plus 0.035 divided by 12, close the parentheses, raised to the 134th. I got $844.17.
Yep.
Good? All right, one more. What interest rate compounded continuously per will be required to end up with $1,000 after 3 years if 890 is initially deposited? All right, so we're gonna use PERT. Would everyone agree with that? Everybody can figure that out. I want to end up with 1,000. I am starting with 890. I don't know my interest rate, but I know T is 3. Divide by 890. I'm gonna go ahead and cancel those so I don't have to keep writing. So 100 over 89 equals E to the 3R. You do not need to do that. If that confuses you, don't do it. Leave it 1,000 over 890. Now what? We're gonna ln both sides. So ln 100 over 89 equals 3R. And then we will divide by 3. ln 100 divided by 89 divided by 3. Now, be careful. I got a decimal, 0.0388. But the question says, find the interest rate. So isn't this 3.88%? Wouldn't that be my actual interest rate?
Yep.
Okay, now I want you to get your homework out, your 3-6 homework. I'm not going to do them all because you need to practice on your own, but I do want to do the last one because it's a little bit weird. So problem number 3 on homework 3.6. So find your 3.6, this is your last homework paper. Well, 3.5, yeah. 3.6 homework. And we're looking at the very last problem.
Problem 3.
Problem 3. All right. When you were born 18 years ago, your parents put some money into an account paying 3.5% interest compounded monthly. The account is now worth 3, 4, 5, 6, 7. How much money did your parents originally deposit? Okay.
I have a question. Why couldn't you just like divide that? Oh wait, no. I was saying, why couldn't you just divide
Alright, so what do we do?
We gotta use the second.
We're gonna use the second formula. How do we know that?
Compound.
Well, it isn't enough to say it's money.
It's
It
compound.
is compounded monthly. That is how you know. Can PERT be done with money? Yeah, if it's compounded continuously. This is monthly. This is my monthly formula, okay? Now, where does the 34,000 number go? That's what I'm ending with. What is P?
We don't know yet.
We don't know yet. What is R? 0.035. What is N? 12, compounded monthly, and would be 12. And T is 18. So let's clean up that exponent first of all. 216. Am I going to use logarithms? No, because the only time I use logarithms is when my variable is up high, right? My variable is up here. Okay? Would everybody in the room agree that this yicky looking thing is a number? That's just a number, right? Got it? All right, so I'm gonna go ahead and figure out what that number is. So 1, well, let's have it in parentheses. I've got parentheses. 1 plus 0.035 divided by 12 raised to the 216. I got 1.875. No, we're not rounding it off. We're not rounding it off. But make sure you got 1.875.
Yep.
Got it? Now, this is 1.8. I need to get P by itself, so what do I need to do? Divide that 1.8 number over, right? So I'm going to type 3, 4, 5, 6, 7 divided by second answer equals. Now, if you have an old calculator like mine, you have to do it that way. Everybody can do it that way. You guys that can highlight and paste, cut and paste, you can do that too. But we're now rounding that number off. Okay, we're going to use our calculator. So once I got that number typed in, I just did 3, 4, 5, 6, 7 divided by second answer. And you should have gotten $18,426.99. So I'll type this in exactly the way it was written. And then I take that divided by that answer. And I don't retype it, I do second answer. There's no sense retyping stuff, you don't need to. Second answer, we'll pull that right down in there for you. All right, did we all get 18,000? Okay. Now, I have a practice quiz. Because we need to take a little word problem quiz. The word problem quiz will only have 2 problems on it. The practice has 4. We'll finish this next time and quiz the time after that. We'll also our practice.
I'm not allowed.
Why are you laughing, Joe?
All right. Everybody got a practice quiz? Problem number 1. Come on, we're gonna get problem number 1 done.
It's the second formula.
Okay, so somebody in the audience has suggested that we are using our compound interest formula, that bottom one.
Yeah.
Remember, that will be written on the board just like it is now. How do we know it's that one? What's the key word? Not compounded, compounded monthly, right? Because if it's compounded continuously, it's PERT. Compounded monthly. All right. How much will she have when she is 32 if she deposits 500? Okay, where does the 500 go? P. Account is paying 2.4%. What's my decimal? 0.024. Compounded monthly means N is 12. What is my T?
14. It's 14.
14. Why is T 14?
Because it's 32 plus.
She's making the deposit when she's 18, and we want to know how much she has when she's 32. That's 14 years, right? So I'm going to go ahead and multiply that 12 and 14. 168. Do I need logarithms? No. I'm going to straight type this in. And she's going to end up with $699.43. Money problems are always rounded to the nearest cent, right? So even if the directions say something different, money always looks like that. Okay, so game plan, tomorrow we finish this practice quiz, start our practice test. Day after that, we take our word problem quiz.
Yeah, so it wouldn't be Wednesday?
Oh, we don't have a class tomorrow?
No.
Okay, so that'll be Wednesday.
Or is that actually really hard to do? Never mind.
When do we go see like a little That's next week. My little kid.
No.
Eighth grade buddy.
Yes, same pilot.
Yeah.
So it'll be
Yeah.
seven. I think that is.